the idea of the equation of path. What's the point? When you think about projectile motion, right, you get a very predictable shape. When you look at this, to establish that it is exactly what you think it is, you need some algebra, right? So you've got parameters and we need to get rid of them. Now, to give you a bit of a parallel to this, we're very used to getting rid of parameters, right? Which topic do we mostly deal with parametrics in? In mixed answers. Mostly we're thinking about just parabolas, right? So you're actually used to this. Locus of the parabola. Right now to this guy you can read focal length and where the directrix is and so on and so forth, okay? Now, the parameter is t. How do I go about, in this case, how do I go about getting rid of t? What do we actually do? You make t the subject of one of the equations. Clearly, x is going to be the better choice, right? Okay. You take that guy, you sub him into the other one, and then out pops this equation, which, lo and behold, has no more parameter in it, right? So you've got parametric equations, and you've got this Cartesian equation, right? By default, for all kinds of standard sorts of projectile motion questions, which have an initial velocity v and an initial firing angle, angle projection alpha, okay, you're going to get the same x dot and y dot, x and y, every time, right? What are you going to get? X is easy first because there's no acceleration acting on it. What do you get? I think you get v t cos alpha from memory, right? Depending on what your initial velocity and angle are, you'll get some concrete numbers in there, okay? In exactly the same way, going off, just depending on what gravity they give you, either 10 or 9.8, you're going to get minus, now what do I have up here? What do I start with? G t squared on 2, right? Because of those two integrations, right? And then you've got the initial upward velocity, right? Yep. Okay. Now, admittedly, this looks a lot more messy than this because you've got trig functions in there and all that, but that's okay because the trig functions are just numbers, depending on what alpha is, of course. So it looks worse, it's not really, okay? Now, what's the clue that tells you these are related to each other when we'll give you a parabola, not just because it looks like it, but algebraically? What's the signal that tells you? It's the t squared, isn't it? It's that guy, right there. That's how you know it doesn't just look like a parabola, it really is one. And that's where you get this result from, which is written in a couple of different ways, okay? You get this. Sometimes you'll get that in terms of tan squared, it doesn't really matter. There you go. So if you like, there's your Cartesian equation in x and y, no time involved, okay? Now, I want you to try using this for this question, number 7 that I've given you, okay? You can see that this kind of equation is going to be more helpful to you if all you're really interested in is where things happen, okay? If you need to know anything about when they happen, you have to appeal back to these equations, right? But if you have a look at the question, and all the different pieces have nothing to do with time, it's just about where do things occur, where am I going to be highest, where am I going to end, all those kinds of things. This is a far more elegant way to go about it. There are less equations to worry about.